I hope you're doing well. Welcome back to my YouTube channel. In this video, I'm going to be taking you through HCAI.com Lab 3.4 on inter-VLAN communication. Inter-VLAN communication. About this lab, VLANs are separated at layer 2 in order to minimize broadcast domains. To enable the communication between VLANs, Huawei provides a variety of technologies. So the following two technologies are commonly used. The first one is .1Q termination sub-interface, and the second one is VLAN if interfaces. So you use .1Q when you're using sub-interfaces on a router, and you use VLAN if interfaces when you're using a layer 3 capable switch. So objectives: to learn how to use .1Q termination sub-interfaces to implement inter-VLAN communication. Learn how to use VLAN interfaces to implement inter-VLAN communication. And also to understand the forwarding process of inter-VLAN communication. So in this scenario, we have this topology here. In this topology, R2 and R3 belong to different VLANs, VLAN 2 and VLAN 3 respectively. And they need to communicate with each other through VLAN if interfaces or .1Q termination sub-interfaces. So that is what we are going to be configuring. So in this particular lab, R2 and R3 are simply they're simply simulating what we call end devices, just like PCs. Okay, so for R2 and R3, we are going to configure them with these IP addresses respectively, and other than that, we are going to configure them with a gateway address. To configure them with a gateway address, we are going to be configuring a static default route. So that is what will act as the gateway address. On S1, on switch 1, this one, we are going to assign gigabit Ethernet 002 and 003 to VLAN 2 and VLAN 3 respectively. So configuration roadmap is to begin with .1Q termination, then we will do VLAN if interfaces. So let's begin with step number 1, configuring the basic configurations. So here we're going to begin by configuring the IP addresses and gateways for R2 and R3. So let's do exactly that. So this is the topology on ENSP. So let's begin by configuring R2 and R3. So on R2, we are going to go to System View, then we get into int G001. We assign it an IP address 192.168.2.124, like that. So after we do that, we can quit. Then we can configure a default static route, which will now act as the gateway. So to do that, we use IP route static. IP route static. Then we use the anycast address 0.0.0.0. The mask is 0. Then we give it the next hop. So if this router gets any packets that is not in its routing table, it should forward it to this next hop 192.168.2.254. So the reason as to why we are configuring this as the next hop is because in configuring the .1Q termination, we are going to be configuring the sub-interface on R1, this one. This sub-interface 1.2, we're going to be configuring it with that IP address. So that's why we want R2 or this end device or access device or terminal to use this as a gateway. So similarly, we do the same for R3. For R3, the gateway will be this one, this sub interface 1.3. So we'll have to give it, sorry, this is wrong. This is supposed to be 3. Okay, so let's configure that on R3. So on R3, we get a system view int G001, IP address 192.168.3.124. Then we quit. Then IP route static 0.0.0.0.0, then 192.168.3, so read.254. Okay, so just like that. And now we have configured R1 and R2. Of course, as it is right now, they cannot be able to communicate with each other. 168.2.1, if we ping R2, we cannot be able to communicate. We cannot be able to communicate with each other. Okay, so let's move on. Let's move on to the next step here. So the next step is to configure R1 and R3 to be on different VLANs by configuring switch 1. So on switch 1, we configure this interface G002 and G003 to be on VLAN 2 and VLAN 3 respectively. So let's do that. Okay. So we want on S1 to configure G002 and G003 to be on VLAN 2 and VLAN 3 respectively. So let's do that on S1. Okay, so we begin here by going to system view and then creating the VLANs. So we're going to use VLAN batch 2, 3. We just want those two. So after that, we can go into 002, then port link type access, then port default VLAN 2, like that. Then we can go to G003, like that. Let's clear this. Then we use the history access. Then we assign this to VLAN 3, like that. So we are done with that. And now R2 and R3 are on different VLANs. At this point, again, they still cannot be able to communicate. They cannot be able to communicate because they're on different VLANs. Okay, so let's move on. Let's move on and look at the next instruction here. So the next instruction is on step 2 to configure .1q termination on sub-interfaces in order to implement inter-VLAN communication. So in order to do that, we first need to configure the link between S1 and R1. That link, we need to configure it as a trunk, this link here. We need to configure it as a trunk, this one. Okay, so that's what we are going to do. And on that trunk, we are going to allow pass VLAN. We are going to allow pass VLAN 2 and VLAN 3. VLAN 2 and VLAN 3. Then after that, we are going to configure the .1q termination by creating sub-interfaces on R1. So let's begin by working on S1. So S1 here. On S1, we go to int G0/0/1, which is interconnecting S1 with R1. Then here we do port link type. By the way, they forgot to screenshot this command, so you need to do it. Just look what happens if I do port trunk. So it can't it can't recognize this command. If I want to do port trunk, this one, if I just want to go to this direct without making it a trunk port, I just go to this direct, copy. So if I paste this and I do enter, it cannot be recognized unless I make this port a trunk first. So port link type trunk. So if I do that, now I can be able to specify VLANs that are allowed to pass on this trunk. So enter, just like that. Okay, so once we are done with that, we can now configure .1q termination on the sub interfaces. So you create a sub interface by simply using the command interface, then the name of the interface, then the number of the interface, then a dot or a full stop, then the number of the sub interface. Generally, it is recommended that the sub interface number be the same as the VLAN ID. It is recommended that you do that because that is how the sub interface knows that this particular packet is supposed to be stamped with this VLAN ID. So you should always make sure that the sub interface number matches the VLAN ID of that particular VLAN that it's supporting. Okay, so we are going to create sub interfaces like that, and then after that we're going to use the command .1q termination. Then we give it a VID of 2, which is now what the sub interface will use to stamp the VLAN ID. So this one, we just give it this, by the way, for remembrance, so that it can become easy to remember that VLAN 2, the sub interface is 1.2. VLAN 3, 1.3. But now, for either removing or adding a VLAN tag, this command enables that .1q termination, VID2. So what .1q termination command does is, when it receives a tagged packet, then it will remove that tag, and it will only remove tags which match with this VLAN ID, this VID here, before processing it or forwarding it. Otherwise, when it receives a packet that is destined for this, then it will add the VLAN tag before sending it out. So that is what .1q termination command really does. The other thing you have to do to a sub interface is to enable ARP broadcast packets to be forwarded, so that the MAC addresses of the interfaces can be able to be learned. So by default, we know layer 3 interfaces will drop any broadcast packet. But if you want it to be able to process it, then the command to do that is ARP broadcast enable. Okay, so of course you can see here we are on the sub interface view. So we are creating 1.2, and we will also create 1.3. Okay, the other thing I did mention, other than ARP broadcast enable, is assigning it. You have to assign the sub interface an IP address. So three things. First of all, you create the sub interface, then you use the .1q termination and you give it a VID. Then you enable ARP broadcast using that command. Then lastly, you assign it an IP address. So let's do exactly that. Okay. So here we go to R1. So here we can now create a sub interface. How you create a sub interface is that way. Then the name of the interface, then 0/0/1, and now dot. So the sub interface for us, we are starting with .2, like that. So after you've done that, then you get to the sub interface view, as you can see. So the first thing we want to do is to do .1q termination VID2. So we can just do question mark. So you specify the VLAN ID. So we want this one to support VLAN ID 2. Then the next thing we'll do is ARP broadcast enable. Enter. Then after that, we can assign it an IP address. So this IP address will be what we've configured in our terminal devices as the gateway. So this will be the gateway for VLAN 2 devices. So 192.168.2.254. So remember, this particular IP address for the gateway must be on the same network segment as the IP segment of that particular VLAN. So it cannot be on a different network segment. So once you've done that, then that is all. That is all. So the next thing you need to do is to create the subinterface 1.3. So to do that, you can just do it from here. Int gigabit Ethernet 0/0/1, then .3, like that. Then we can use now the command .1q termination vid 3 for VLAN 3. Then after that, we can use the command ARP broadcast enable. So I'm using tab to autocomplete there. Then we can give it an IP address 192.168.3.254. The subnet mask length is 24. So enter, like that. So once we've done that, now we should be able to R2 and R3, which are our terminal devices, should be able to communicate with each other. So just to capture that communication so that we can be able to understand it better, we can do a data capture on this interface. So remember that so we can see that that interface is actually receiving a STP or MSTP packets from S1. Anyway, remember that this particular interface, as it is right now, it is actually two. They're actually two interfaces. Let me see if I can draw. So that interface has been divided into two, like that. So that's how really it looks like right now. Okay, so at this point, let me just do a ping from R1. Let me do a ping from R1 from R2 to R3. So if we do a ping here, we can ping R3. R3 is on 192.168.3.1, like that. So if I do that ping, we should be able to get the reply. And you can see that those particular packets have been captured here. So we know that by default we send 5 requests and we get 5 replies if everything is okay. But as you can see here, for example, if you count the ICMP packets, we have 20. They're actually 20 if you count them one by one up to here. They are 20 instead of 10. The reason as to why they are 20 is because, as I said, this is how the communication here works. R2 sends it to S1. S1 sends it to S1 will send it here, like that. So remember, this is the request. Then it will be sent through this subinterface, will be sent through that sub interface back to the switch, then finally to the destination, like that. So you can see if we do a data capture here, one request will be captured twice as it goes into the router and as it goes back into switch 1. So that's a single request. The reply, again, for the reply, same thing. When the reply is sent, comes from R3, goes to R1, like that, then sent back to the switch via G0012, then sent back to R2. So you can see that one cycle captures 4 packets. So if you're having 5, then it's 4 times 5. And that now explains really how we are getting 20 packets here. But other than that, you can see that the first thing, or the first packet we are sending really, is the ARP broadcast packet, who has 192.168.2.254. So our R2, which is our host, is going to find out the MAC address of the. It's going to find out first the MAC address of the gateway, because that is what it will use as the destination MAC address. So of course the gateway will reply. The gateway will reply. Now, as the gateway replies, the gateway will also go ahead and ask who has the MAC address of this destination where this guy wants to go to, so that now when it's forwarding this particular through this particular interface, then it's able to use that destination MAC address. So it will change. This packet will be changed at this particular point. The destination MAC address will be changed. No, the source MAC address will be changed, and also the destination MAC address will be changed. Both of them will be changed. So I hope you understand how that happens from the theory class that we learned previously. Okay, so we can see that R2 and R3 are now able to communicate. The other thing we are going to do is to do a transat just to see and confirm that indeed that particular ping, or when we want to go here, it will be sent to this particular gateway and then finally delivered here. Okay. So let's do that. Let's use the transat. So we can transat 192.168.3.1, like that. Enter. So if I blow this out, we can indeed see that it first gets to R1 on the sub interface 1.2. Then R1 will search its own routing table and find out that this one is a directly connected network, and therefore it will simply forward it out through the sub interface 1.3. If we want to even understand that better, we can, for example, explore the routing table of R1. If we do display IP routing table and we press enter, we can indeed see that if R1 gets a packet going to this network, whose destination address belongs to this network, it's going to send it to this next hop via this sub interface. Gigabit Ethernet 0/0.12. So you can see that will be the outgoing interface for any packet whose destination address belongs to that. For any packet whose destination address belongs to the 3.0 network, the next hop, outgoing interface .13. You can see Gigabit Ethernet 0/0/1.3. So you can see that all of them are directly connected networks on this particular router R1. So that is it about the .1 queue communication, .1 queue termination. So let me just explain that uh, at this particular point, this guy R1 will receive on this interface. It will receive a tagged. That's why we made this a trunk. Sorry, it will receive a tagged packet, but it will remove that tag. It will remove that tag before sending that particular packet to this subinterface. It will send it to this subinterface by looking at the routing table, which we've just looked. So that's how it processes it. Then when this guy receives it, it's gonna of course tag it with VLAN 3. It's gonna tag it with VLAN 3 and send it back like that on the destination IP. Then, of course, this is an access. We configure this as an access, so it will remove the tag and send it out to R3 like that. On the other hand, when let's look at how the opposite of that. So this one sends untagged. The switch will tag it because we've configured this G003 with a port VLAN ID of 3. Then it will send it to this guy. So this guy again will remove the VLAN 3 tag, then send it to this subinterface. This subinterface will tag it with the VID, .1 queue termination VID 2. So it will tag it with VLAN 2, then send it to the switch. So that is what happens. Then finally, of course, it will arrive to the destination. Of course, this interface is access, so it will remove, this one will remove the tag before sending it out to R2. So that is how that particular communication really happens. Okay, so let's move on and look at how to configure VLAN if interfaces. Now, the preceding configuration that we just did, we use that. We use that when we are using a router. But in case we don't have a router and we want to enable inter-VLAN communication, then we can use a layer 3 switch and we configure VLAN if interfaces. So that's what we want to learn. Before we do that, we just want to delete the previous configuration, specifically the link between S1 and R1. So we just want to undo. We want to use this command, undo port trunk, so that we no longer allow this, and we also undo the link type for that particular interface on S1. After that, we are going to undo the sub-interfaces also on R1. So let's just do that. So I think we can begin with R1. We can undo interface gigabit Ethernet 0.0, 1.2, and you can use the history to go back and just change 3 there. Then we can go to S1. So on S1, we want to go to gigabit Ethernet 0.1. Then we want to undo. I had copied, paste. We want to undo that. Then we undo port link type. So if we do display this, then we don't have any configuration there. Okay, so once we've done that, creating VLAN if interfaces is easy. The command is interface VLAN if, then the number. That number is the VLAN ID, So after you've done that, you simply give it an IP address. And after you've done that, you can create the VLAN if interface for the next for the next VLAN, which is VLAN 3, then you also give it an IP address. Maybe before we configure the VLAN if interface, we can test the connectivity between R2 and R3, which are our end devices. So if we test the connectivity at this point, it should fail. It should fail. Okay, so let's go ahead and configure the VLAN if interfaces on the switch. So the command again is interface, then VLAN if, like that, then question mark. So it's supposed to be the VLAN interface number. So we just give it 2 for VLAN 2. Then we assign it an IP address just like a layer 3 interface, because so 192.168.2.254, then 24, like that. So similarly, we can create VLAN if 3, enter. So you can see that the view, we are now on VLAN if 3. Then you can configure an IP address. So we just change this to 3, enter. And so after doing that, if we do a ping between R2 and R3, we should be able to ping R3. You can also use Trasat to see how it goes. So you can see if we do Trasat, then it goes indeed to the VLAN if interface, then it's routed back to the destination. So ladies and gentlemen, this lab was quite short, and that is how you configure .1q termination interfaces or sub-interfaces, and also how to configure VLAN if interfaces on Huawei switches. Thank you very much for your time. Make sure to go through the question at the end of this lab and try to answer it. Asanteni sana.